So today we'll start talk about the state of matter and the change in temperature. We'll go through just a melting point, and then in another lesson we'll talk about the other type of change. So what happened to state of matter as temperature change? So here I will take the water in my experiment or my example after a few minutes, because you have an example in your book about the ice and water, and you should make this experiment, but because we can't make this experiment, I will help you to understand all that without this experiment, so don't worry. So what the meaning of phase change? The phase change that when the state of matter change from solid to liquid to gas. This is a phase, and that is phase change from liquid. This is a liquid phase, this is a gas phase, and this is a solid phase. So the phase change that mean we transfer from one phase to another phase, okay? And again, we just talk about solid, liquid, and gas, and not about plasma. So here we just have a three type of phase: solid, liquid, and gas, not plasma. We don't talk about plasma because that is not found in your book. Okay, so don't ask about plasma. So phase change. Okay. He take here example about ice, and he talk about ice cup, and he asked if I increase the temperature for this ice cup, what happened to it and why he melt. Okay, and what will happen to the particle inside this ice, and we'll understand everything about that, okay, after a few minutes. Okay, first we should understand that the matter change its state when it gain or lose an amount of energy or thermal energy. So if I change the thermal energy that matter or particle have, that means the state of this matter will change. So that means when I change the thermal energy, that means the temperature change. So if I change the temperature by increase or decrease this temperature, the speed of particle will change too. So we have a thermal energy. If I change the thermal energy that particle have, the temperature change, and because the temperature measure the average of movement or average of kinetic energy that particle can have, that means the speed will change too. So all these depend on each other. So the thermal energy change, then temperature change, then the speed of particle change. Okay, and in the end, if the speed of particle change, that means the state of matter change too. So before we go to this, I will go with you here to understand that. So we'll study the state of matter. Okay, this is a phase change. Just let's go to the phase, to this state. So look here, we have a solid state, and we have a liquid state, and we have a gas state. So what happened here? What's the difference between these three states? Each one of it have its own thermal energy. So the solid have different thermal energy than liquid and gas, and liquid have different thermal energy than gas and solid, and the same for gas. So, and temperature here is different. So you can look at the temperature, and the temperature is different too. Okay, because we have a different thermal energy, that means the particle have a different speed. So here just stay in its place, and here slide, and here just have a random motion, and is more faster than liquid and solid particle. And that this is a three state of matter. Okay, so solid, liquid, gas, solid, liquid, gas. Okay, so if I change the thermal energy, the temperature change, the particle speed up, and that means we change the state of matter. So look again here. If I change the thermal energy, look at the thermal energy, I will change the thermal energy, and in the result the temperature change and the particle speed up, and in the end what happened is this particle change from the solid state to gas state. So it's transfer from solid to liquid to gas, from solid to liquid to gas. Okay, so we have a solid state, we added an amount of energy, so it transferred to a liquid state, and then liquid state transfer to a gas state. So we transfer this matter from one state to another by change the thermal energy, and in the result the temperature will be changed and the particle will speed up. Okay, so the particle speed up, if the particle speed up, that means we have a different kinetics energy, and that means we'll have a different temperature. Okay, and now we can back to the melting point. Okay, so the particle in a solid, okay, is held together, so it's very close together. Okay, so the particle inside the solid, like ice, is very close to each other, and that means the attractive forces between this particle is very high. We have a very attraction force between this particle. Okay, so the attractive forces between this solid particle is very strong. We have a very strong attractive forces here. Okay, now if I added an thermal energy to this particle inside a solid state, so it start to move away from each other, and this energy that particle take from again from thermal energy will help the particle, okay, itself to break down the attractive forces. Okay, and in the end this particle will move from one state to another state. Okay, and when the particle take this thermal energy and transfer from solid to liquid, okay, from solid to liquid, okay, when we added energy, thermal energy, and the particle gain this energy and transfer from solid state to a liquid state, okay, that called a melting point. We have a melting point. Inside this melting point, the melting point is that temperature when the solid state transfer to a liquid state. Okay, so and this temperature will stop increase just when all the particle inside the solid state convert to a liquid state. So we will back here to understand that here we have a solid state, we have an ice. Look at this particle here, and we will try to add a thermal energy. What happened here is this thermal energy will transfer from this source of energy to the ice, and what happened is that this particle, just I want it to be in liquid state, so this particle is transferred to be in liquid state. Okay, that's what happened. So when we added energy to the solid state, I will add just a few amount of energy to this solid state. So what happened here, that is transfer to a liquid state. Okay, at this point when the solid state transferred to a liquid state, the temperature in this way called a melting point. Okay, and if I added more energy, if all the particle here become in a liquid state and we don't have any solid state here inside this particle, all this particle is in liquid state, that means if I added any type of energy, any more in amount of energy or thermal energy, this energy, the particle will take this energy and move faster. Okay, so this particle will take this more energy, we added more energy, and this particle will take this energy and move faster. Okay, and that's the meaning of this word here. Okay, so the temperature stops increasing when it has a melting point. When in melting point, the temperature will stop increase. Okay, and the melting point is that temperature when the solid state changes to the liquid state. That's the meaning of melting point. Okay, so that's the meaning of melting point. So any energy we added to this ice, okay, will help the ice to break the attractive forces between the particles. So look here, which one of this state have more attraction? Which one of it have more attractive forces? So the much or very strong attractive forces will be found in the solid state. As you can see here, the solid state, in solid state the particles very close to each other. That means the attractive forces in solid state is higher than the liquid state and higher than the gas state. So the solid state here have a very high attractive forces. So when the particle become very close to each other, that means the attractive forces is very strong. Here in liquid, the particle have not this far, it's not far away. Okay, the particle is not really far away like a gas, but the attractive force of it is less than the solid. Okay, so that here in the gas we have a more space between particle, and that means we have a very low attractive forces between this particle. And here in a solid state, this attractive forces is very strong, so we have a very strong attractive forces. So to break this attractive forces, or to break down this attractive forces between a particle inside the solid state, we added a thermal energy. And look how it's vibrate, and then that means it's try to break this force, and you can see how this particle now is free to move inside the container. That means this particle break down the attractive forces between each other, and that means we added a high energy. So when we added energy to this particle in solid state, we break down this thermal energy, help the particle to break down the attractive forces between each other, and in the end this particle will be move and free to move inside this container. As you can see here, look at the particle is have a free motion inside the container, but here now it just close to each other and cannot move. Here it's become have more space, so it's not really free, but have a good motion between each other. Okay, so it can be move. Okay, but in gas it can be moved in any direction, in any way. Okay, inside the container, so it's free to move inside this container because we have a random motion, and that's why we have a random motion. Okay, so when in the last thing I will talk about that, when we added thermal energy, again when I added thermal energy to this particle will move faster.